Internet Protocol version 6, or IPv6 for short, is the latest version of the Internet Protocol, which identifies devices across the Internet so they can be located. In the next few minutes, we will look at the layout of IPv6, compare it to what we know about IPv4, and where to go from here. But before we can get into all that, we need to go back and take a look at how we got here. Before the launch of IPv6, the Internet relied on IPv4, its predecessor. When IPv4 was initially implemented in the 1980s, almost no one could have predicted that we would one day have more than 4 billion devices connected to the Internet. Keep in mind this was an era when an IBM PC Junior or Apple IIe was state of the art. In the first decade of use, it became apparent that IPv4 would run out, and so development began to create an Internet protocol that was much, much larger. Thanks to the growth of personal computers, smartphones, and eventually even devices like smart speakers, watches, and TVs, we began to run out of addresses even more quickly than we first expected. The Internet Engineering Task Force, IETF, created IPv6 and it became the draft protocol in 1999. IPv6 is a 128-bit addressing system that has 340 trillion addresses. In other words, it's really big. ARIN began allocating IPv6 in 1999. As predicted, supply of IPv4 could not continue to meet demand, and ARIN's free pool of IPv4 address blocks was exhausted in September of 2015. And from that point on, it became more important than ever to begin the migration to IPv6. Let's take a look at IPv4 and IPv6 side by side. First, consider the address size. IPv4 is a 32-bit number, and IPv6 is a 128-bit number. Their address format is different as well. IPv4 is formatted in a dotted decimal notation, while IPv6 is a hexadecimal notation. Between IPv4 and IPv6, the common block sizes and therefore their prefix notations are also very different. We'll come back to block sizes in just a minute. The difference in the number of addresses between IPv4 and IPv6 can be hard to process. IPv4 has just over 4 billion addresses. IPv6 has 340 trillion addresses. That's called an undecillion for those who are curious. You might find that IPv6 addresses are hard to understand, particularly if you're used to looking at IPv4. Let's take a moment to break it down. Most of the time, an IPv6 address is split 50-50 between the network address on the left side and the host or interface ID on the right side. If this were a mailing address, the network address would be the street name, and the interface ID would be the house number. Although there are many different possibilities, this idea represents just one possible configuration. In this example, the first part would be the routing prefix, which is assigned to a customer by ARIN or your ISP. The second part indicates the subnet created by the customer at a site. That third part, the interface ID, is the unique identifier for a device connected to the network. Although an IPv6 address in hexadecimal notation is longer than you might be used to seeing, at least you don't have to read it as 128 zeros and ones like your computer does. Instead, all those ones and zeros are broken into 8 groups of 16 bits each, separated by colons, and then represented in hexadecimal, so we only have to look at 4 numbers or letters for each group. With IPv6, you can build an addressing plan that allows you to actually see where an IP address is coming from just by looking at it. Let's build a quick sample address to understand. This first section shows where your block came from. This one is from ARIN. This next group designates a region or site location. In this example, 0 indicates a specific region, and 234 designates a site within that region. Some address plans break it down even further, it just depends on your needs. The next group can be customized to designate subnets at that 234 site that we referenced earlier. We have over 65,000 subnets available to use there. The last section is an auto-configured 64-bit unique identifier for that device. Now that we have looked at the format of your address, what about block size? The smallest issued IPv4 block size from ARIN is a /24. This gives you a pile of 256 addresses to start building your network. Many are surprised that the smallest issued IPv6 block is a /48. However, with a /48, you get over 65,500 subnets, each with over 18 quintillion individual addresses. If you receive an IPv4 block from ARIN, that block would help you begin to build your network. However, with IPv6, you can not only build your initial network in more detail, but you also have room to expand for the future. Simply put, IPv6 allows you to do more and go further. Need specific help? We're here for you. You can always reach out to our Registration Services Department via phone or ask ARIN online.